Now let's talk about friction resistance, which sounds like it would be a big problem, but it's really not as big as we think it's going to be. We'll look at wheels and we'll look at the drivetrain as well. Friction resistance. This is due to resistance or friction in the drivetrain and also in the bearings. Now, when we're looking at friction from ball bearings, we have to make sure we do this scientifically. Usually, this is a very tiny effect. If a hub is properly adjusted and it's in good condition, the amount of resistance is going to be very small. If the hub is too tight, then you can get bearing friction and you can also get increased wear. Remember that skewers will tighten the bearings somewhat when you close them when you put the wheels in the bike. The bearing preload should allow for the effect of tightening the skewer. There's a copy of a hub or a scheme of a hub from Park in case you're unfamiliar with some of the components of a hub. Now, if you need any proof that the bearing resistance from wheels is as low as I claim it to be, all you have to do is look at a bike shop, and if you look at wheels that are hanging in a bike shop, you will see always the following. These are actually a couple of wheels that I built, and if you look, I've labeled where the seam is. At the bottom of the rim there's a seam. So there was a tiny bit of extra weight in the bottom of the rim where the seam is compared to at the very top of the rim where there is a small hole for the valve. That difference of weight is enough to cause the wheel to always settle with the slight extra weight where the seam is at the bottom. If there were any appreciable friction in the ball bearings of the hub, then that would not happen. Now, steel ball bearings and ceramic ball bearings are not the same. We have to make sure we're comparing apples to apples if we're comparing ball bearings. Ball bearings vary slightly in roundness. On the right there, we see a 1/4 inch ball bearing that's a 1/4 inch plus or minus, let's say 0.01%. Another ball bearing that you might use in a spaceship might be a ball bearing that's 1/4 inch, but it's plus or minus 0.001%. So the bottom ball bearing is obviously more spherical, more exactingly spherical than the one at the top, even though the one at the top, 0.01, is a very small deviation. Other ball bearings can be slightly rounder. So we have to make sure that when we're comparing ball bearings, we're not comparing rounder, say, ceramic ball bearings with perhaps less round steel ball bearings. And that's what I mean by comparing apples to apples. Here's my opinion about the whole thing. Ceramic ball bearings are possibly better, but I think they are largely not worth the expense. That's my personal view. And it's because steel ball bearing resistance is very, very small anyway. So by going to ceramic, you're possibly at most getting the small improvement to a very small problem. With respect to the drivetrain, we have to keep the friction low there, but that's not too hard to do. Make sure you have a clean and lubricated drivetrain and replace worn out parts. If you do that, your drivetrain friction is going to be kept pretty small.